Hi everyone. In this lesson, we'll begin with one of the most important ideas in statistics, the Central Limit Theorem, or CLT. You'll learn how to recognize problems involving sample means when the Central Limit Theorem applies, and how to find the mean and standard error of the sampling distribution. Then we'll finish by working our first example. Let's begin. The first step is recognizing a sample mean problem. Look for words like sample mean, average, or mean of a sample. These tell you the problem is asking about x bar instead of an individual value x. Why does that matter? Because problems involving sample mean use different formulas than problems involving individual observations. For example, if a problem asks for the average exam score of 50 students, you are working with a sample mean. If it asks for the score of one randomly selected student, you are working with an individual value. Always identify what the problem is asking before choosing a formula. Now, let's introduce the Central Limit Theorem. The Central Limit Theorem tells us when the sampling distribution of the sample mean is approximately normal. There are two situations where we can use it. First, the population is normally distributed. Then the sampling distribution of the sample mean is also normal. Second, even if the population is not normally distributed, the sampling distribution will still be approximately normal when the sample size is large enough. In this course, we'll use the guideline that n is greater than or equal to 30. The key idea is that averages from large samples tend to follow a normal distribution, even if the original data do not. This is important because it allows us to use the normal distribution to answer probability questions involving sample means. Be careful not to confuse the population size with the sample size. The rule applies to the sample size, lowercase n. So what exactly is a sampling distribution? Imagine taking many random samples of a sample size from a population and calculating the average for each sample. If you graph all of those sample averages, you get the sampling distribution of the sample mean. Instead of studying individual observations, we are studying how sample means behave. As we work with sample means, you see few symbols. Mu represents population mean. Sigma represents population standard deviation. X bar represents sample mean. Mu of x bar is the mean of the sampling distribution. Sigma of x bar is the standard error, and n is the sample size. Now, let's look at the formulas you use throughout this chapter. The first one is the mean of the sampling distribution. Mu of x bar equals mu. This means the center stays the same. The average of all sample means is equal to the population average. Next, the standard error of the sampling distribution. Sigma of x bar equals sigma over square root of n. The standard error measures how much sample means vary from one sample to another. Notice we are dividing by the square root of the sample size. As the sample size increases, the denominator gets larger, so the standard error gets smaller. That means larger samples produce averages that are more consistent and stay closer to the population mean. Finally, we write the sampling distribution as this. This tells us the sample mean follows a normal distribution with mean mu and standard error sigma over root n. Before we work our example, remember these two ideas. The mean stays the same. The spread gets smaller because we're using the standard error instead of the population standard deviation. Whenever you see a sample mean, ask yourself whether you should be using sigma over root n instead of just sigma. Let's work our first example. A population has a mean of 80, a standard deviation of 20, and a sample size of 25. We are asked to find the mean and standard deviation of the sampling distribution x bar. We'll start with the mean of x bar. Mu of x bar equals mu, and mu is 80. So the mean of x bar is 80. Next, let's find the standard error. We use the formula sigma of x bar equals sigma over root n. Sigma is 20 and n is 25. So we have 20 over square root of 25. And the square root of 25 is 5. So we have 20 over 5. And 20 over 5 is 4. So the standard error is 4. Finally, we can write a sampling distribution as x bar follow a normal distribution of 80, 4. So the sampling distribution has a mean of 80 and standard error of 4. Notice that the standard error is much smaller than the original population standard deviation of 20. That's because averages vary less than individual observations.